Welcome to the session for new programming languages on Z. My name is Iris Baron. Said I'm from Toronto Lab. I'm technical advocate for runtimes on Z. In my background, I worked before that 15 years mainly on Java, JavaJit. So now I want to introduce you to a new language. So before I start with Node, I will go 2 steps back. And we'll see that today we are supporting actually 3 modern languages on the platform. We have Java, which is not new, celebrating now 20 years on Z. Node, which I'll cover today. And we also have Swift. So I won't be able to cover those other languages, but there are plenty of talks and sessions in Share covering more updates of those languages. So please come and see us there. OK, so what we will do today, we will start with JavaScript, as this is the core language for Node. And then we'll talk about Node. We'll talk about popular frameworks and popular usages for Node. And in the last part, we'll talk about Node on Z and what's the new status of it. So first, JavaScript. JavaScript is the main language and the core for Node. It's a scripting language. So it was first introduced by Netscape in 1995, not new. And the main purpose was to give dynamic content to pages. Today, together with HTML and CSS, it's one combined part to representing web pages. Since it was introduced, it was standardized under ACMA script, which is today in version 8, I believe. And JavaScript is basically a dialect of this standard. And there are others. Most of the browsers today, and I believe all, are embedding a JavaScript runtime in them. And popular ones, Google with V8, Microsoft Chakra, Apple has Nitro, and Netscape SpiderMonkey. So this is a nice picture. It's a car on the left. I know it's a Ferrari, but it's a car. And on the right, it's a carpet. What do they have in common? Nothing besides the name car in the name. And similarly, Java and JavaScript. It has a Java in the name, but nothing to do with Java. Different languages, different purposes. One scripting, one dynamic, completely different. So please don't mistake. JavaScript is not Java. OK, so why do we talk about JavaScript? JavaScript is today a very popular language. If you look on any survey that you will put your hand on, you'll see that Java and JavaScript are at the top. If it is GitHub, depending on number of repos, Stack Overflow on discussions, and many RedMonk, every other survey, you will see JavaScript at the top together with Java. And what's this survey here that I brought, it's from a Stack Overflow survey. With asked user, and probably there are 38,000 responses. What's their popular language that they use? And 62% respond with JavaScript. So it's very, very popular. And why do we care? So Node was later introduced. And what I didn't mention before, that JavaScript was used in front end, has no capability to do anything from the back end. It was basically displaying web pages. And then came Ryan Dahl in 2009 and said, oh, why should I use JavaScript for server side? And that's where Node came in. So it's basically using JavaScript as a server side. Today it's governed by the Node Foundation with the community, of course. It's built over the Google V8 runtime, cross-platform. Everything is open source. And it's ideally used for network applications. And that is data-intensive I/O bound applications. And the way it's dealing with this and allowing you to scale very well for network applications and have multiple concurrent connections is by having an event-driven, single-threaded, non-blocking I/O model. And that's very important to the scalability of Node. And what does it mean? Basically, we have one single thread that goes, you get tasks. If you can handle them, you will quickly. If not, you pass it to the backend workers. And they do the work. When they finish, they notify him, and he finishes the transaction or the task. And I'll show you in a second a little bit more. The other point here is modularity, which, again, we'll talk some more about it, but it's a crucial part for agile development. OK, so this picture is kind of an analogy to the event-driven single-thread non-blocking I/O. And we look at a fast food restaurant in this case. And we have one cashier and many people coming in and standing in line. And each one goes to the cashier, places its order. The cashier, if he can handle the order right away, will do that. If not, he will send it to the back, to the folks at the back, and let them do the work, whether it's burger, fries, whatever. When the order is complete, they notice the cashier, and he will finish the transactions. So you have one single cashier, similar to the one single thread that we have, but it can handle many, many customers. And they're not blocking, meaning that they're not waiting for the other to finish the transaction. Please ask me questions anytime. I didn't say I have a tendency to rush, but I'm be very happy to answer questions. OK, so what Node is comprised of? It has three main parts. One is the V8 engine, which we mentioned before. It's the Google V8. It has libuv, which is a part that's actually dealing with the event module, and core libraries, different libraries to do different things like zips. What I want to point here is that besides the V8 in Node, it's used in other places. For example, MongoDB, Ruby Racer, and some libv8, which is several Linux distributions. Ubuntu is one of them, and I heard there is another, but I can't replace the name. So why Node and JavaScript work together so well? First of all, JavaScript is very popular. We saw that, so many developers available, easy to find skills. It has a large ecosystem behind it. So I mentioned modularity. The module system is huge in Node, and people contribute continuously to this, and it's growing all the time. Today we have more than 90,000 modules available in those repositories, everything open source. So what it means and how it fits to the agile world is that you don't need to rewrite everything. You'll probably find it in one of those modules. When I say module, if you think about it, it can be something very small like uppercase conversion, and it can go very complex things like a complex server or even a full stack, which I'll mention more about it in the next slide. So not only you can reuse, but makes your life easy in terms of testing, writing code, easy to deliver, fast delivery, fast testing, continuous integration. All those goes together with modularity very, very well. Last thing here is the community. Other two things that make it even better is that the battle between the browsers. So there is a competition on performance between the runtime environments, and V8 was improved as well. So if in the past we looked at JavaScript and we say it was interpreted, today we have a JIT for V8. So things are moving and getting better. Other thing is battle-tested frameworks. So frameworks, I am saying it's like a large module. And there are ones that are very popular, very well tested. You can use them, make your life much easier. So I mentioned the modular system, and Node Package Manager is actually the repository that handles all those modules. It's a public repository, and we can see how huge it is. Basically, if you look at the right, this is taken from modulecounts.com, and I updated the picture last week. I'm pretty sure that we already crossed the 600,000. Because you see the rate, the red line is actually the NPM for Node, the modules for Node. We can see not only that it's much higher than all the other modules for other runtimes, but the speed that it grows, it's amazing. It's 3 times faster than other modules for other runtimes. And just to put your ear, it's like more than 500 modules per day are contributed, which is enormous growth, you know, like really, really amazing. And you can find everything. You want to do something, you first look there to see if you can easily find the module you need. It saves you a lot of time to rewrite. Okay, so with this, I want to go on and start talking about some popular frameworks and make some order, because there are so many and the names are coming up and you have no idea to replace it and what does it mean. So we're first going to look at Express. Express is a server-side framework. It's one of the most popular. And the way to look at popularity, you can pretty much look at the GitHub and see how many stars they have. And it's kind of a good indication where it is. It's a very basic. I'm not going to go very detailed about it, but I'll give you a little bit of introduction to it. It's very basic framework, easy to install, but you can say everything that you download from NPM, easy to install, because you just use NPM install and voila, you got it. So what's nice about it is that it's JavaScript, so it's like all the Node applications. It's JavaScript, so it talks the same language as the front end. And people like it, especially in enterprises, that you maybe don't need 2 different teams that speak different languages, and you need to see how you integrate between them. So what else? On Express, many other frameworks were built on top of Express. For example, cells and loopback, which are very popular by themselves, have Express inside them. But there are many other server-side frameworks that are also gaining a lot of popularity, and it's very opinionated which one to choose. Koa, for example, and Meteor, and there are many others, many others. The difference between the frameworks, it's how much flexibility it gives you. If you have a client interface to generate automatic code for you, if it fits to the MVC module or not, testing maybe. But those, what's the main purpose for it? So, for example, you can have web server application, and you can have REST APIs application servers that are more concerned about creating those REST APIs. So loopback, for example, is one of those REST APIs. And you go through a client interface, you put your modules that you need, and it creates automatically the whole code for you, everything, with all the APIs that you will need. Then you can extend it, of course, but it gives you, out of the box, quickly, a working application. Express is a little bit different, and we'll use it as an example to a Node application. So this 6 line here, it's all you need to get an Express server up and running. And what it means, let's just go over it quickly. First line has, if you see, a require. That tells it that you will require the Express module. no. So the question was, do you have to npm install Express first? And I'll get to it in the next slide. It's a good question, and if I don't answer, please remind me, okay? I'll go first on the code, and then we'll see how to install it, okay? So require means that I need the Express module in order to run this. We start the Express. We define some routes. In this case, we define one route, a get. So it's a URL / that's the request that will come in. And when the server will see this request, it will send a response back of hello world. Then we define the listener. So we say, the server, you need to listen in port 3000. And when you do this, just put out the log. You run this, and voila, the service is up and running. You can connect to the URL. You get the hello world. Everybody's happy. So, and then you can expand it, right? You can have more routes. You can have more tasks done in the back whenever different routes come, like controllers, modules. But I'm not going to get to it now. So let's talk now, use this example as an anatomy to a Node application. So usually when you write an application, you want to have a package.json in your project. This is like a certificate of your application. It includes a lot of things important, like the name, the version, where to start, what's the main files that you need to call to start your server. A list of dependencies that you will need for the project. So even if you don't download the dependency, you can transfer the code together with your package.json to any other hosts, and then do the npm install to get all the dependencies there. So to get the package.json, you'll do npm init. It will ask you a bunch of questions, and you create your package.json. Now, every JavaScript source file has a .js at the end. And so now we need to install those modules, right? So if you have everything defined in your package.json, all you need to do is npm install. And it will read those dependencies and will go and install that for you. So you were asking me about that. You can do npm install Express anytime. If you'll try to run the code that I show you without install it, it will complain. It will say, I don't have the modules available. So you'll know to install them. And to run, you just do node and whatever is your main file to run. In this case, it's app.js, but it's typically a server.js or anything else. So in this case, just as an example, so I didn't have the Express in the package, and I did npm install Express. And what we see here is the list of all the dependencies that Express is dependent on. So it went and installed all of those, and you can see actually which version it is, so on. And on the right, what we see is how it shows. So it's pretty much a Node modules directory. And underneath, you can find all this information. Each one of the dependency has a directory, and each one will have a package.json of its own with its dependencies. But your npm install will take care of doing everything for you. Now, I do include a -- save there. What it means is if you have a package.json, take this module and put it in the dependency for your project. So next time, you don't have to carry all those Node modules with you because it's already registered in your package.json that you need Express. Any questions about that? Good. OK, so now we are going to talk. So we kind of covered the server-side web server frameworks. And now we are looking at a little bit higher level, which is a full stack framework. That meaning end-to-end solution. So it's called software solution, for example. And in this case, as an example, again, there are many others. I'll give you one. It's a min stack. And min stands for Mongo, for M, Express, for E, Angular, and Node. And if you think of any application, web applications that you're going to write, you need three main parts. You need the client, you need the server, you need the database. And this has it all. It has MongoDB as a database, Express is the server, Angular is the front end, and Node is the platform to give you the capability and the power to do scalable network applications. So altogether, you have a full solution to create your web application. So what's the advantages of using full stack? First of all, it's all JavaScript. So you don't need different skills in your enterprise. You can have even one team, one guy doing everything. Easier, it's really easier on the companies to deal with one skill rather than two different teams or three different teams to collaborate. Small learning curve because it's all JavaScript, very straightforward. Everything open, everything is free. Again, it's a continuous improvement because there are continuously contribution from the community to get it better. There is some history about Min because it started as Min.io and then it forked, and today there is another one, minjs.org, and there are some differences. You can read about it. I'm not going to get to it. Yes, question?
Have you used React yet with it? How does that fit in?
I'll get to it.
Okay.
So the question was about React. So here we see the other point here is that everything, because in JavaScript, it's talking JSON. So JSON is a JavaScript object notation, pretty much a representation of data in a humankind form. So it comes in pair of key and value. Very easy to understand if you look at this. And they all communicate like this. So I'll get to your React question, don't worry. I didn't forget. So MongoDB is one database which it's JavaScript, and it's no SQL, so it's nothing to do with our old relationship tables. It's all JSON today. This is JSON document, and there are other databases that can fit in because they are JSON oriented. So here's an example of how you communicate with an update. And you can see the JSON here query. It's the JSON data in the query, and it's pretty trivial to understand what it's doing. I don't need to go through it. Angular is another one, and it's not another one. It's a framework for the front side. So it's very, very popular, I have to say. Supported in all browsers, and people love it. But there are many other frameworks to work with the front end. This is an MVC framework built to support dynamic web applications. And originally, it was used for single page applications where you don't want to load the whole page. You just want to load the parts that you are interested in. Like if you click in on one section, you want just to reload this one without refreshing the whole page. But since then, it's evaluated, and now it's used in many, many web applications, and people love it. The gentleman here asked me about React. So React is it's a competitor to Angular. And it's opinionated. There are pros and cons. You can read about it. The main difference, as far as I know, is that React is dealing only with the view side of the framework. So if Angular was dealing, MVC stands for module, view, and controller. So it has the module, which is dealing with the data. It has the view, which is a representation on the GUI. And it has the controller, which is kind of the business logic. So, and it takes care of all those integration. React is it's a library, it's not a framework, so it's only taking care of the view. And you're supposed to bring in the other parts, other frameworks. Again, people are opinionated. You can read different blogs about what's best and which one will say different things. And so this is Min, but there is Mern also, and which is with React. So there are different full solutions with different technologies that you can pick off. From my point of view, it's all under Node, and we are promoting Node, so it's kind of a way to show you how Node is used. And there are many companies that are actually using Mean. Google, Netflix, PayPal, those are big advocates for, in general, for Node. So if you look online, I'm sure you'll find lots of talks, videos from them as well, advocating Node. Okay, so with this I'm finishing with frameworks, and we'll go over some use cases. And well, this is not pretty much a use case, but Node becomes more and more a big player in the digital transformation world. And big companies as well as small companies are picking it up as the main player. And why is that? So we talked about simplicity, JavaScript, easy to learn, easy to use, very light, very efficient language. We talked about full stack development, perfect for agile. We talked about modularity. So modularity allows you to write less code, and what it means, you have less code, you have less bugs, you need less testing. It all comes together. Development is faster, so the cycle of development is faster. Moreover, you know, people move today from monolithic approach to microservices. The monolithic approach, when you have a huge application and takes forever to test and change and risk to break anything, is going out. And instead that, microservices come in. And this means that you break down your application in little pieces, and that's exactly what modular world with Node can help you in. And this allows you better control of your code, easy to debug, easy to find problems, easy to change. You have better control overall on your application. So it fits better in the agile world, where you want maybe to deliver quickly. I know Netflix was talking about they need to deliver every day a new page, a new content. They don't have time to test everything, take down, replace. Like everything needs to be fast, so they probably have a microservice that's doing it, and they just update this one. So performance, we talked about Node. It fits very well to the web applications capable to handle multiple concurrent connections. We saw how it's doing it. Other things. It suits very well to the API economy, works well with REST APIs. There are frameworks built especially to provide you a REST API server. Speak JSON, so can fit to, talks well to the front end, to databases. Open architecture, sorry. It's, everything is open, and because it's so, the community contributes so much, you can find everything. You can connect to any device, any database, any platform. It's all in there, so it's well integrated. And what I want to mention is that because it's so popular and those NPM modules exist, it's kind of a cycle. You know, people see it's popular, they want to try it. They try it, they maybe want to contribute back, so the number of modules increase, so people see it's now more popular. And it's kind of a cycle, and it grows. But it's good. It means that if you need to find skills, you'll easily find ones for JavaScript and Node. In surveys that we had from 2016, we saw that there are 11.6 million developers using JavaScript. So skills are there, easy to find. Other common uses, we talked about microservices. We talked a little bit about web services, but there are different kinds of web services, and it fits all, especially real-time applications, messaging, chatting, collaboration, gaming, all those can fit as well. You can have a node serving as a gateway to do load balancing, proxy, authentication, stuff like that. You can use Node as API orchestration. So you can think of an app that you have, for example, to compare flight prices. So you can have different microservices that talks to different sites of different vendors, and then you want to collide them, compare them, and get a response back to your user. So you might want to use kind of an orchestrator for this. We are all speaking Z, so ZOS Connect, for example, is built to give you access to your data assets at the back. So you can have an API for Kix and an API for IMS, API for DB2, and you can put Node in front of the OS and has it an orchestrator to all those APIs. So you can combine your answers and send it back as possible use. Caching, another thing, and presentation layer, it's now getting more popular as desktop applications, so on. Okay, questions about so far?
Could you share an example of how you would architect a microservice application? How would you kind of orchestrate the services so that entire application lifecycle that kind of can make the microservice support, or is there a framework that supports that?
So the question was, how do you architect your microservices?
Yeah, fair enough.
I guess it's per enterprise. I don't have an example with me, but it depends what you're doing and how much you want to break down those tasks that you have. If you have a monolithic one, you need to be smart in putting little pieces that make sense together. I don't have a better answer than that, but if you look online, you'll see some stories from different companies that present their architecture and explain about it. I know I watched Netflix, but there are others, and they explain how they went from monolithic to microservices, and that may be going to help you. So now I'm going to talk about Node on Z, what's new about it, new status, so on. So maybe we should start. I know it's overwhelming, but I'll take you through it slowly. Why we need Node on Z? Node is Node. It's the same thing running anywhere, similar on Z. But we will have a benefit of running on IBM Z because all the goodies that it provides. So today, we have two flavors. We have a Node on Linux on Z and Node on ZOS. On Linux on Z, we are compatible with version 4, 6, and 8. 4 is coming out of service very soon. On ZOS, we are on version 6. And I highlight here some of the benefits of running Node on Z. So first of all, scalability. We talked about Node being a platform for scalability of those applications for non-blocking I/O. If you use it on Z, you take advantage of the asynchronous I/O that the IBM Z provides, and you can get much better performance. And I'll show you a slide with performance numbers, and we'll talk about it. In addition, you get just pure performance improvements from running it on IBM Z because collocation. I can't emphasize enough how much important is collocation. The closer you put your data, application to data, the better is the performance. And I heard it in few sessions yesterday, and I think it's something you really need to understand because it will improve your performance. You can put your microservice, for example, on a distributed platform, it will work, but if you put it on the platform, it will work better because it will connect to your assets in a better way, faster way. In addition, we are using hardware exploitation. I'm not talking about the numbers because I'm going to talk about them more detail in the next slide. We do hardware exploitation. We use, like in Java, we use instructions, the instructions to improve performance. And Security, of course, Z is a trusted platform, especially with Z14 and pervasive encryption. You get better security. In IBM SDK, we have an addition, for Node, we have additional trace points that we add to work with our tooling and unified tooling that we use also for Java, like Health Center. And the last part is better connectivity with ZOS assets. So we are working today to build more and more connectivity to those assets. We have DB2, we have connected to vSAM. I know there are folks from Kix that are interested to know if you are interested to have Node inside Kix, let us know. We will be happy to hear from you. Working very well with ZOS Connect. ZOS Connect provided two connectors, actually, one for pure Node to talk to ZOS Connect and discover APIs, and one through loopback. So if you use loopback, you can pick up as a data source ZOS Connect, and it will ask you, okay, which APIs. It will discover you all the APIs that are available to use, and you can build your application like that. So we are working to kind of bring together to the ecosystem all the connectors, and we'll get to have a full solution. So it's like we use this slogan in Java, Java and Z better together. It's the same for Node. With having the Z underneath gives you more power. Sorry. Okay, collocate. Doesn't want to work? Okay. I guess it doesn't want to stay on this slide. Completely doesn't. Okay, anyway, I'll take you back to the numbers from. Okay, sorry, it's not my fault. Yeah, it's a PowerPoint fault. Okay, we'll blame PowerPoint.
It's a slide automatically switch to next slide.
Yeah, but I can't even go back to the previous. Never mind. So from collocation, what I want you to take, the picture was showing that you can put your backend server in a distributed platform outside of Z, and you can connect to DB2, to your Kix. This is not this slide, I'm sorry, but I can't move this one, and I don't want to talk about the previous one. So you can connect functionally, it will all work. You can connect to database on Linux. But if you'll take your backend and put it on Z, you'll get better performance. And we tested an application that was talking to DB2. So we put it on Z Linux, and we put it on X, an equivalent X. And that was just putting queries to DB2 on the OS. And we got 2.5 times better throughput using Linux on Z. And we got 60% improvement on response time when using Linux on Z compared to the X alternative. So collocation matters. I see. If you think about it, putting it on actually ZOS and connecting to DB2 will have better numbers. Yeah. Sorry, the guy.
Yeah, does JavaScript and Node.js take advantage of the Z processor?
I'll get to it. Short answer, no. Yeah. Okay, so ACMER. So this is another test that we did. It's ACMER. It's an open source application that simulates booking flight tickets, and it has three parts. It has a server, which sits here, a Node server, either on Linux, on Z14, or on X. It has a client, which is actually a JMeter that pumps in connections data, and it's talking to MongoDB. And we see that in terms of scalability, on Linux, on Z, we got 2.5 times better than on X. So you can, just to put it in perspective, if you have 1,000 connections with X, you'll have 2,500 connections with Z. So that's a lot. That's a big, big improvement. So why not take advantage of it, right? Another test that we did also Acme area, just to show you that we are getting improvement release from release. It's all Z13. We are working now to get the version 8 numbers, but we see that from 4 to 6, there was 26 improvement, so quite a lot. So where we are in development process. So for Linux on Z, Node is pretty much contributed back to the community. Those are links to the V8 and Node in the community, and you'll find them, the distribution for Linux on Z as well. For IBM, and also we have the IBM SDK builds that we have through IBM. You can get those from Docker. First one, Docker pull node will get it for you from the community. The other will get the IBM SDK. Those are free to use. For ZOS, we maintain still the GitHubs for V8 and Node, VN as an IBM runtimes. But you can all contribute to it. It's open. If you want to contribute, you just do a pull request. We'll love to hear. Love contributors. libuv is already pushed back to the community, so it's part of the general libuv under Node. We do try to stay current with the community, so Linux usually comes very soon. IBM SDK comes very soon after the community. And we have our own communities that you can join for Node at IBM. And as I said, we are contributing all the time, modules, we are actively participating there. So maybe I'll talk a little bit what's the difference between IBM SDK and the community, because I said there are two. 99% of the code, exactly similar. No change. It's the same node, basically, that's what I want to say. We do have extra Rust capabilities, as I mentioned before, some tracing. We do security fixes and license and code scans pretty early, so IBM is more rigid in terms of response time for security, for example, vulnerability. If there is, we probably will put a fix sooner than the community and then push it back to the community. We do all the license fixes ahead of the community, usually. So where we are in terms of versions, version 8 is now the current. Version 6, it's now in a long-term service. I think it ends next year. And version 4, it's very close to end of service. So, and end of April. So if you're using version 4, make sure you're going to change it. For IBM on ZOS, IBM Node on ZOS, we are in version 6. If you want to see, we are working towards version 8, and everything in the open, you can go and look, see our progress there, and contribute as well. This page here shows you the community for testing the node. So there is a continuous integration page that keeps continuous testing all those components. We can see here Node, Linux 1, and funny, it's not so funny, it's very fast compared to the other port platforms. You'll find here the Node, the V8, you'll find tests for libuv, also on the OS because we pushed it already to the community. And now I'll talk a little bit about Node on the OS. I have another session on Thursday when I'll talk a little bit more about the ZOS side. Basically, as I said, it's based on version 6. It was announced in July 2017, together with the Z14, if this day doesn't ring a bell. And since then, it was GA'd in September, so it's kind of pretty new, 6 months, something like that. It's an offering, so it's not free. It's, you can get it from Marketplace. You can install it with SMPE, single SMPE. And to answer to the gentleman, it's not zips eligible, but it is a candidate for container pricing. So if you have a new application for Node, it fits into the container pricing new application. Of course, it needs to be approved, but it fits there. So I don't want that the offering will scare you. We have 2 trials modes that you can use to download the ZOS, Node on ZOS, and try it. One is through the Marketplace, that evaluation license for 90 days that you can get. It's an SMP install. So you can download, test, see if you like it. The other one is through the development work. It's a PAX format. Again, it's the same level as the GA one that we have. So you can go and download, and if you have comments to us or anything that you see that we need to improve, please let us know. If you want to be a sponsor for ZOS, we really, really love to hear from you, because we want to know what else. We need other connectors maybe, where to invest to bring it even further, more appealing to the crowd for ZOS. Okay. Tooling. So we put also, not on the development side, but also developing tooling. I know people care about it a lot, and it's something important. So as I said, we have RAS capabilities that we included in order to collect traces from the node, and we are trying to get a solution, a unified diagnostic with Health Center. And Health Center is a tool, if you're not familiar. It's an Eclipse-based GUI that you can monitor your application, and it gives you a picture of different components on your application, from memory, CPU, garbage collection, hotspots like profiling data, etc. It's great for Java. It's good for Node too. The other one is AppMetrics, which is a dashboard monitoring tool. In addition, there are other tools that come from the community, and we participate as well to give solutions for ZOS. For example, the Node report. So the Linux on Z is through the community, and the ZOS is through us. And that gives you kind of a human readable report of the crash and all the stack of JavaScript and native languages of its users. HipDump, it's another tool from the community. And iNode, it's still in progress. It's kind of a debugging way to analyze and inspect different parts of your node. Is it a stack and object and so on. So you can get everything from us. Okay, so I'm happy to answer questions now. I know we have more time, so please. Yes, please.
Do you want hosting on C, as far as security goes and auditing the app, anything to share about that when you kind of setting it up for hosting a web app, like just secure it on and
How to do security?
yeah, security to make sure that it's kind of, you know, is there anything to share about that?
Not so much. It's pretty much like any other application, the way you deal with it. Nothing special about it.
Integrated with RACF, any app, like if you want to implement any RACF, is it not?
No, RACF is not integrated. What we have is that there is a connector that was published that you can access data, I forgot the name, sorry. But you can access and see all your data stores and so on. So HFS, and you can get this information. Sorry, yes, please.
From your perspective, could a Rex programmer come up to speed quickly on JavaScript and Node.js?
Sorry, say it again. Sorry, I didn't hear the beginning.
Yes, from your perspective, could a Rex programmer come up to speed quickly with Node.js?
So I don't know, because I'm not a Riker developer, but yesterday we had a gentleman from USAA that provided his experience, and he said that he had PL1 developers and system admins that were put to task with Node, and they were easy for them to learn. So, yes. Oh, sorry. So the question was if a RecF developer can easily, Rex developer can easily come to speed with Node and JavaScript. And to my opinion, the answer is yes. It's very trivial language to learn, very simple. I do want to mention that there are many, many resources. Those are highlighting, a lot of them are ZOS. On the Linux, it's more easy because it's similar to the other Linux environment. We are going to put soon a Z-trial, if you're familiar with the Z-trial system for more applications. We are going to have Node on Z as a Z-trial, so you can go register and play with it there. And there will be a lab at Think, if you're attending that, about Node. So it's speeding up. I know it's still early, especially for ZOS, but it's coming up. We have users that are interested, and I'm sure we'll see it growing through the years more and more, because it has a lot of good stuff to provide. And yeah, sorry.
Do you also offer AIX support on Node on AIX?
There is an AIX support.
There is
yeah. Okay. And last thing that I'll say is that we need your evaluation. So please.
Thank you.
Thank you.